Alrighty, we're continuing on our review of Chapter 6, Chapter Review. We're in Chapter 7, Section 3 for Part 2 here. And essentially, they're asking us to simply graph. Okay, now, graphing is could be a complicated thing, but oftentimes it's much easier than people want to admit. Okay, because in order to graph this function, we simply need to get a series of points, x and y's. So I'm going to make up some points. I'm simply inventing my own independent variables. I put this exponent, this x, -2, right here, where this goes. Okay? And that will tell me what my y is. Of course, this is y. What's the difference between y and f of x? It's the same thing, for the most part. Okay? So, what we're saying here is if this is -2, then this is the problem. So we got to work this out. Because of the negativeness, what we see here is actually the other way around. This will be 4 to the second power. Notice it was a -2 when it was this way, but now that I flipped it and fixed it, we don't need the negative anymore. This is the regular number. According to our order of operations, 4 times 4 is 16. And when I take 16 times -4, I will get the answer of, I don't know, -64. So that's 1 point. -2, -64. Okay, let's do another one. -1. That means this, which means this, which means this. So my point is -1, -16. 0. I have the same regular equation, but to the 0 power. Now, any number, including a fraction, raised to a 0 power is actually just 1. So this is my next point. If this was a 1, then this would be like so. And what this means is -4 times 1 would be -4 on top, 4 on the bottom. My answer would be -1. Therefore, that's the next point. If this was a 2, 1 to the second power would be 1 on top. 4 to the second power would be 16 on the bottom. And that would make it like so. -1/4. My point would be 2, -1/4. Now, truth is, we need to graph. So, once we do a few points, I got my 5 points here that it took a little bit, but doesn't take forever. I'm going to graph my points. -1, -2. Here's 0, 1, and 2. Now, I'm not going to do -64. I'm not making those little hash marks, okay? But what I will say is starting at 2, okay? Here's 1, here's 2. -1/4 is right here. 1, -1, that's 1, -1, right here. 0, -4, right here. Are you starting to see how this is curving down? -1, -16, okay? This is my curve. Okay, that's my graph. Now they're also asking me to identify the asymptote. Okay, the asymptote is the line that our curve does not cross. You'll see it begin to bend before it gets there. And what is the name of this line? Our asymptote is going to be y equals 0. What is the domain and range? The domain, okay, would be how far does it go to the right? Forever. How far does it go to the left? Forever. The domain is all real numbers. All right. Finally, the range. As you can see from the graph, it's all of the numbers below the asymptote. So it's all of the y's less than the asymptote. That's my asymptote, that's my domain, that's my range, that's my graph. That's how you do number 12. You do the same thing for 13. You do the same thing for 14. You just have to make up your x's. You put these x independent variables where the x goes. You then solve out what your f of x would be, graph, etc. Okay. Now, let's go ahead and do the next couple of sections here. Exponential growth and exponential decay. Exponential growth, okay, means that it's going up by multiplication, by an exponent, okay? Let's take a look here. In number 17, every time we have an independent variable, what's happening to our y? It goes from a 3, a 6, a 12, a 24, okay? What you're noticing here is that this is actually multiplying. 3 times 3, 3 times 2, 6 times 2, 12 times 24, 12 times 2 is 24. Each one of these little steps here is times 2. Okay? That's what we're saying here. That's what we're saying here. Now, take a look at the next one here. This one, to go from 162 to 108, it looks like you're going to have to subtract 54? 54, right? I think. Okay. This one, from 108 to 72, you're going to have to subtract, let's see, 36. From here, you're going to have to subtract 24. Okay. Now, what you're noticing here is that as the x's go on, the y's do not follow any pattern. There is no pattern here. It's neither a growth or decay. Here, you can see that each one multiplies by 2. That is a function of growth. All right. Now, let's take a look at 19, 20, 21. In 19, 20, and 21, we are using this formula. Okay? This is the A. This is the B. Okay? And then we have the exponent. Okay. Now, that's our exponential formula. When we're talking about exponential growth or exponential decay, this is our formula. Where our variable x is now t for time, and our base, the thing that gets exponented, is actually 1 plus however fast the growth is. This is growth. 1 minus the rate would be decay. Now let's take a look here. All they want us to do here is to determine whether the function represents exponential growth or exponential decay. Now, in our formula, this middle parentheses part would be 1, and it would either be plus or minus, right? It says 1.25, so it went up from a 1. This is proof that this is exponential growth. Okay? We're done. That's it. Now, how much did it grow? Well, it was a 1, and now it's 1.25, so it went up 25%. Here, this went up 0.06. That went up 6%. This is the growth. And then, of course, 0.84, that's less than 1. It used to be a 1. Now it's 0.84. That went smaller. That is what we call exponential decay. And how much did it decay? Well, it went down 0.16. So it went down 16%. All right. Now, that's phase 2 of chapter 6. Check out the third section here in a little while. Good luck, and if you have any questions, you go ahead and let me know.